All right, y'all, so today we're going to talk about finding inverse trig functions. Now, we're not going to go super heavy into inverse trig functions. We're not going to graph them. You're not going to transform them, anything like that. We're just going to talk about finding the values of inverse trig functions. And we're going to start by talking about the graphs of cosine and sine. So for a function to have an inverse function, it must be one-to-one. We talked about this just a little bit way at the beginning of the year. And to test that a function is one-to-one, we use the horizontal line test. So we go horizontally, and if at any point we're touching multiple spots on the graph, then it fails the horizontal line test. Now, the reason why this is important, the reason why it's important for a function to be one-to-one, is because if a function is one-to-one, that means it has 1x to 1y, which means every point on the function is unique. Which is important because if you remember, when we're finding inverse functions, we're going to switch x and y. So if we have repeated x's or repeated y's, when we try to do that switching process, we run into a little bit of a problem. Okay? So that's why it's very important for a function to be one-to-one for us to be able to find an inverse. So we want to think about how can we fix that, because it fails for both cosine and sine the way they are now. So starting with the cosine function, how can I make it so that the y values are only covered once so that I can make this a function? So let's start by graphing that cosine function. So our parent function following that same pattern, high, mid, low, and then mid, high. And we'll do the same thing in the negative direction too. All right, so now that we have that cosine function graphed, what we can see clearly, same as before, is that it would fail the horizontal line test. But is there any way that we could possibly take maybe just a snapshot or a piece of the function and still have all of those important values? Because we talked about this a little bit. All of our trig functions have a very important relationship, and is that they are oscillating functions. They repeat their values. So after a certain point, after we've gone a certain amount of our trig function, we're going to account for all the values that we'd see on the unit circle. So we can do the same thing here, because between 0 and pi over 2, we're going to get positive 1, root 3 over 2, root 2 over 2, 1/2, and 0. And then from pi over 2 to pi, we'll get negative 1/2, negative root 3 over 2, negative root 2 over 2, and negative 1. So those 7 or so y values are really all of the values, all the important values on cosine that we need. So we can take just that small portion of our cosine function and take the inverse of only that piece. So we call this process restricting the domain. And the idea is to limit the x values so that the function is now one-to-one and would therefore pass the horizontal line test. So see how that's our key thing that's in common, is that one-to-one and passing the horizontal line test. Okay, that's why we're restricting the domain. That's why we're taking this smaller piece. And if we remember back, if we hearken all the way back to our unit circle, what two quadrants of the unit circle are these first two pieces of our cosine function? Well, it always starts 0 to pi over 2, that's quadrant 1, and pi over 2 to pi, that's quadrant 2. So we are actually taking quadrant 1 and quadrant 2 of our unit circle. And that's what we're going to be using when we're talking about inverse cosine values. So let's scoot on over. Okay, what is the domain of the restricted function? So what would the domain be of that smaller piece? So we're taking it now from 0 to pi. So those x values that we're restricting our domain to would be bracket 0 to pi and then bracket, because we're including all of those values. And then what is the range of the restricted function? Well, remember, we wanted to get that entire range of our original cosine function. So we're getting -1 to 1. So we're still going all the way from -1 all the way up to +1. So we're restricting to that same domain. Now when we take the inverse, we're going to switch x and y. So what should also switch? Our domain and range should switch. So our domain is now going to become the range of our restricted function, -1 to 1. And the range of our inverse function is now what the domain of our restricted function was. So now we want to talk about, why is this important? Why are we doing all this? Okay, the reason why we're actually finding these restricted values, as I lose my black pen forever and always, is we're trying to solve this equation. If cosine theta equals √3/2, what would theta equal? And we want it to have only one answer. So going with the original cosine function, the answer would be the two different values on the unit circle where theta is equal to √3/2. So one of them is pi/6, and one of them is 11 pi/6. And remember, these are from the unit circle, so if you forgot, we would go to our unit circle. At pi/6, x's are positive, and the point is √3/2, 1/2. And at 11 pi/6, x's are still positive, and the point is √3/2, -1/2. So these are the two angles that if we plugged into cosine would give us that value of √3/2. Okay. Now going with the inverse cosine function, so if we take cosine -1 of √3/2 equals theta, what would theta be? Well, there's only one answer, and the answer is pi/6, and that's because pi/6 is in the restricted domain. So pi/6, 11 pi/6, we go back up to that restricted domain. The restricted domain is 0 to pi. So which one of these falls in between 0 and pi? Well, it's only pi/6. So that's why pi/6 is our final answer. So if f of x is a function, then the corresponding inverse is denoted by f-1 of x. With trig functions, there are two ways that we denote the inverses. The inverse of cosine is denoted cosine -1 of x or arc cosine of x. Once we get up to higher level math, so once we get into calculus, arc cosine, arc sine, and arc tan are almost exclusively used, but we still use cosine -1, sine -1, and tan -1 because that's the notion that our calculator uses. But we'll use both of them interchangeably. So let's jump over. I'm going to let you do sine and tangent on your own, see if you can figure them out. But let's go over and let's look at an actual question. So let's look at 6. Cosine -1 of -0.5. So let's do ourselves a favor. Let's change cosine -1 of -0.5 to be something we know a little better on our unit circle. So cosine -1 of -1/2. So I want to find what this value is. So notice that we don't even really have an equation anymore. We're not saying when this is equal theta. If you would like to, you can say cosine -1/2 equals theta. So you know that we're solving for an angle. Okay, so we want to think where on the unit circle, what are the two spots where cosine is equal to -1/2? Well, if we go to that unit circle, okay, x is negative over in quadrant 2 or quadrant 3, and it's equal to -1/2 at two spots at our pi/3 angles. So cosine is equal to -1/2 at 2 pi/3 and 4 pi over 3. But remember, we have that restricted domain, so we're only going to use one of the two angles. So what's that restricted domain for inverse cosine? It is 0 to pi, so which one of these falls in between 0 and pi? Well, it's 2 pi over 3. So we eliminate 4 pi over 3, and 2 pi over 3 would be our answer. So this was our goal. This is why we talked about inverse cosine, so that we could still get that entire range, but then we can limit these questions down to a single answer instead of having multiple answers, because multiple answers isn't that fun. Okay, so let's do one more. Let's talk about 10. So 10 cosine -1 of -1. So think on the unit circle, where is cosine equal to -1? So luckily, there's actually only one spot on the unit circle where cosine is equal to -1, and that's all the way over here at pi. Okay, so this time, because there is only one unique value for -1, we only get pi. Now we still want to check, is pi on that restricted domain 0 to pi? It is, so pi would be our answer. Okay, so just to recap, let's write down some steps, because you know me, I always love steps to give you. Okay, so number 1, we're going to find both angles. 2, cross out angle, not in the domain. And then step 3 only applies to sine and tangent. Okay, and you'll see it later when you figure out sine and tangent. I'm going to provide you with the notes so that you can copy them down after you kind of explore with them on your own as well. Okay, but this third step is to change quadrant 4 angles to a negative coterminal. And you'll see what that means when you explore a little bit more with sine and tangent. If you have any questions, please feel free to raise your hand. I will come over and help you out, give you a little help in class. But hopefully this was useful. And now that you've noticed, not only do you need to know the unit circle, but now you have to know it backwards. So as we said, the unit circle always comes back around. And after we finish up graphing, we're actually going to use it a lot over the next 2 or 3 weeks here before and after spring break. So thank you for paying attention. Hope this was helpful.